An AC generator is a device which converts mechanical energy into electrical energy. The essential parts of an AC generator are field magnet, armature, slip rings, brushes and shaft. Field magnet is a powerful permanent magnet or an electromagnet. Armature is a rectangular coil ABCD. The coil has many turns of copper wire wound over a soft iron core. The soft iron core increases the magnetic flux and supports the coil. Slip rings R1 and R2 are two hollow metallic rings which are connected to the armature coil ends D and A respectively. B1 and B2 are two flexible metallic plates or carbon brushes. B1 and B2 are in contact with the slip rings R1 and R2 respectively. They press themselves against the rings and pass current to the external circuit. Shaft rotates the conductor coil. Working. The basic principle of alternator is electromagnetic induction. The principle states that EMF is induced when a conductor coil rotates in a uniform magnetic field. The currents will flow when a load is connected in between the output terminals of the brushes. Consider initially the coil is perpendicular to the magnetic field. During the first quadrature rotation, coil side AB moves down and CD moves up. During this cycle, the current in the coil flows from D to A. In the external circuit, the current flows from brush B2 to B1. For the second quadrature rotation, the current reaches 0. For the third quadrature rotation, the direction of current is reversed. This is because the EMF induced in the coil is of negative value. Thus, the current alternates between positive and negative peak values when the coil is rotating in a constant magnetic field. Position. At any instant, the EMF induced in the coil is given by the formula shown. Now, let us see the different positions of the coil and induced EMF. Initially, the coil is in vertical position. In this position, the EMF induced in the coil is 0 because the line on the plane of the coil is parallel to the direction of the field. As the coil rotates to a small angle, the EMF induced in coil increases. When the line normal to the plane of the coil is at an angle 45 degrees to the direction of the field, the induced EMF is E0 sin 45. In the horizontal position, the EMF induced is maximum because the rate of change in flux linkage is maximum. On further rotation, the value of EMF decreases and it reaches 0 at theta equal to 180 degrees. During the next quadrature rotation, EMF induced in the coil is as shown with a negative polarity. Thus, when the coil rotates in a magnetic field, the induced EMF is sinusoidal in nature.